Hello viewers, it's good to have you back to this YouTube channel. There's quite a lot in stock in this video. Kindly do well to stay to the end so that you can get a lot of value. Today we'll be looking at the algebraic expressions as shown. And these algebraic expressions have been expressed in terms of n. So there's a relationship between the algebraic expressions and the letter n. And this is explained during the course of this video. Before we proceed, it will be appreciated if you can kindly subscribe to this channel and also hit the notification bell so that you are promptly notified of videos that are uploaded on this channel. So we will be looking at the following expressions: x plus 1 over x is equals to n, and then other algebraic expressions will be derived from this particular expression. So this expression here will be like the foundational expression through which other expressions will be derived. Now, based on derivation, x squared plus 1 over x squared is equals to n squared minus 2. In case you have not seen my earlier video where some of these were derived, kindly wait to the end where you see a link through which you can click and watch this. It's very well explained in that video. Also, we'll be looking at x raised to the power 3 plus 1 over x raised to the power 3, and it gives us n cubed minus 3n. You will also see other expressions for n. So these algebraic expressions, so we have other algebraic expressions. For instance, we have x raised to the power 5 plus 1 over x raised to the power 5. And that can be expressed in terms of n. That is n raised to the power 5 minus 5 n raised to the power 3 plus 5n. What this simply means is that if we have an algebraic expression, for instance, x plus 1 over x, and that of course is what we call n, we can simply obtain the value of x raised to the power 5 plus 1 over x raised to the power 5 by simply substituting the value of n into this particular expression. Similarly, x raised to the power 6 plus 1 over x raised to the power 6, we have also expressed in terms of n, and also the value of x raised to the power 7 plus 1 over x raised to the power 7. This also has a value that is expressed in terms. So similarly, for x raised to the power 8 plus 1 over x raised to the power 8, we have the algebraic expression, but this time in terms of n. So there is an expression in terms of n. We also have an expression for x raised to the power 9 plus 1 over x raised to the power 9 as has been provided. Also, we have an expression for x raised to the power 10 plus 1 over x raised to the power 10. So I would like us to look at this table. Let's start from the top. And what we can see from the top, it says let x be equals to 2. Then x plus 1 over x is equals to 2.5. And what we have whenever we have x plus 1 over x, we call it n. So if we just look at serial number 1, column 1, we have x is equals to 2. X is equals to 2 is what we have in column 1. So if x is 2, what do we have for 1 over x? So that's 1 over 2, which is half, and that's 0.5. So what do we have for x plus 1 over x? That is 2 plus 0.5, which is 2.5. And we are calling it n. So our expression x plus 1 over x, which is our foundational expression, we will be calling it n. But we know what our n is from what we have calculated. We have n to be equals to 2.5. So what we are just simply doing in this particular table, let's go to line 2, is to substitute what the value of x is and then solve. So x squared, which is 2 squared, will be 4. 1 over x squared, which is now 1 over 4. That's 1 quarter, which is 0.25. So by the time we add x squared plus 1 over x squared, that is 4, and then 0.25, we have 4.25. And then we do the same for all the values, all the way to x raised to power 6 on this particular table. And then we get all the values we have on the right-hand side. So that's how we are getting these values on the right-hand side. So what we did was we said let x be equals to 2. And then the objective is to actually solve for column 3. The objective is to solve for column 3. But in solving for column 3, what we did is to get the values in column 1 and then the values in column 2 and then add them together so that we can get the values in column 3. Or if you want to do it directly, you can just get the value of x, which is 2, and substitute it directly for you to get all these values in column 3. So similarly, we know what our x is. Our x is equals to 2. And by the time we substitute 2 raised to power 7, we get 128. And by the time we say 1 divided by 128, we get this value. And of course, by the time we add x raised to power 7, which is 128, and we add it to 1 over x raised to power 7, which is 0.007813, we obtain 128.00781. If we carry out the same thing for this, and also for the others here, we get our expressions as we can see above. So the whole thing is to solve for x raised to power 7 plus 1 over x raised to power 7 in this case, and then x raised to power 8 plus 1 over x raised to power 8 in this case, in order to get these values, x raised to power 9 plus 1 over x raised to power 9, and then x raised to power 10 plus 1 over x raised to power 10. So what we will be doing in this particular table is to compare what we have on the left-hand side, that is what we have in this column. That is what we have on this left column with what we have on the right-hand side column. Now take note, on the left-hand side, we have x plus 1 over x and we have 2.5. Remember, we did this from x plus 1 over x up to x raised to power 10 plus 1 over x raised to power 10. We just looked at that a few seconds ago. Now, if you substitute x is equals to 2, that is for everywhere you see x on column on the left-hand side, which is what we have just done, these are the corresponding values we get. Now, but if we use the equations which were expressed. For instance, since we know what n is equals to 2.5, n is equals to 2.5, and then we substitute n squared minus 2 based on the formulas that have been previously derived, we will get the terms here, and that is the same as what we have on the left-hand side. Now, if we look at x raised to power 3 plus 1 over x raised to power 3, we have n cubed minus 3n. We know what our n is. Our n is 2.5. That is 2.5 raised to power 3 minus 3 times 2.5. And we get 8.125. We see that is the same value on the left-hand side. And it's the same value we get using the same n is equals to 2.5. And then the formula we have on the right-hand side. So what we have seen clearly is that when we use x is equals to 2, that is, we solve for the values on the left-hand side, we also get what we have on the right-hand side when we use the particular formula. We know what our n is. We established that n is equals to 2.5 right from the beginning because we obtained our n from x plus 1 over x. And that was what we got, 2.5. That's how we got 2.5. And so if we substitute the value for n in any of these equations, we will obtain what we have on the right-hand side in comparison to what we have on the left-hand side. So we can see what we have on the left-hand side and what we have on the right-hand side for the same values, x9 plus 1 over x9 on the left-hand side in this particular instance. And if you look at x raised to power 9 plus 1 over x raised to power 9, what you get is the same thing. And the same thing for x raised to power 10 plus 1 over x raised to power 10. So these show that the algebraic expressions that were derived previously are correct. But I'd like us to note that we are looking at a scenario where x is greater than 0. That is, x is positive and x is not 0. And x is also not negative. So let's quickly look at this example and we will apply some of the things we have learned. So it says, given that x plus 1 over x is equals to 3, what is x raised to power 3 plus 1 over x raised to power 3? Remember, we established that x raised to power 3 plus 1 over x raised to power 3 is equals to n raised to power 3 minus 3n. Therefore, we already know that n is equals to 3. Therefore, we substitute n is equals to 3, and we have 3 raised to power 3 minus 3 times 3, which is 27 minus 9, and that gives us 18. So the answer to x raised to power 3 plus 1 over x raised to power 3 is equals to 18, given that x plus 1 over x is equals to 3. Thank you. Thank you once again for watching this YouTube video. Remember to click on these videos which are currently being shown so as to watch and benefit from other YouTube videos on this same topic. Do also be kind to subscribe, to like, and to share. Thank you.